Okay, so let's look at 8, 9, and 10 from the Chapter 7 homework. So in this one, let's see, student enrollment of a high school was 1310. That's our initial population, initial value. That was in 1998. And it's increased by 10% a year. And then give an equation that models the enrollment E in terms of T in the number of years since 1998. Okay, well, you started with 1,310 students. So this should feel like the tuition problem or the population growth problems that we've done. And so those all have the same form. You start out your population, or in this case, your enrollment, it's always an initial value. And then it's either times the growth factor, growth or decay factor. And then that's raised to the number of years that you're examining. Okay, well, we have an initial value. That's 1,310 students. And then it increases by 10% a year. I don't want to just put 10% here. I want 110% because it's the 100% I started with plus the 10% increase. And then that gets raised to the t. So this right here is an equation that models it, the enrollment in terms of t years since 1998. And then that's it for 8. That's all you have to do. In number 9, it says we've got a decay, y equals 1250 times 0.085, times 0.85 to the t. And we need the initial amount, the decay factor, and the percent decrease. Well, okay, let me just write it here. Well, okay, the 1250, that's your initial value. And if you're not sure why, well, initial usually means when time is 0. If you plug in 0 for time, 0.85 to the 0 is just 1. And then you've got 1250 times 1, which is just 1250. So 1250 is your initial value. Okay, this thing right here is your decay factor. 0.85 equals the decay factor. And why is it the decay? Well, it's less than 1, right? If you're multiplying by less than 1, you're decreasing. The 1 would just be flat 100%. Okay, and the percent decrease. Well, normally we have 100%, and we had to get rid of something to end up with 85%. So the amount that we got rid of was 15%. So the 15 here, 15% is the percent decrease. That's this. Okay. And then it's a decay model because, well, we're decaying. We keep getting smaller and smaller as time goes on. All right. Then this last problem here. You invest $500 into a stock, and the stock decreases by 2% a year. So find the error. Okay, well, this is correct, right? If something increases or decreases by a set amount, it's always the initial value times the decay factor in this case because it's decreasing to the t. Well, the mistake here is if I'm decreasing by 2% a year, I don't want 500 times 2%. If I'm decreasing by 2% a year, I really want 500 times, and that means I have 98% left. So times 0.98 to the t. So really the mistake is right here. That should be a 0.98 instead. Okay. Hope that helps.